Welcome to the subject on mechanical measurements. This is session 2. In this session, we are going to start the following contents: terms related to measuring instruments, errors in measuring instruments. Then we are going to see an introduction to thread micrometer. What are the terms that you are supposed to know when it comes to the mechanical measuring instruments? You have come across the word range. In day-to-day language also, day-to-day life also, you come across the word range. Range is nothing but the highest possible value which can be measured by an instrument. So it is mathematically defined as maximum value minus minimum value. For example, if you have a scale which measures 15 centimeter, then its maximum value is 15 centimeter, minimum value is 0. So the range of the scale is 15 centimeter, like that. So range is basically the highest possible value that can be measured by an instrument. Similarly, you should also know the meaning of least count. Least count. Least means minimum. So least count, it stands for the capacity of the instrument to measure the minimum distance accurately. So the word least count is related to the accuracy of the measurement. The least count is the difference between the value of the main scale division and auxiliary division. In this diagram, you are having a vernier calipers where the method of finding the least count is explained here. Least count of vernier instruments is calculated like this. LC is equal to value of minimum division on the main scale. So this one is the main scale. Up to this, you can see the main scale. What is the minimum division on the main scale? That you should write. Then number of divisions on the auxiliary scale. Auxiliary scale, suppose it is a sliding one. How many divisions are there on that sliding scale? That is auxiliary scale. That you should note down. So divide minimum division on the main scale. This is the main scale. Minimum division or value of one division here. Then divide it by the number of divisions on the auxiliary scale. So least count, in broader terms, we can say that it is a least measurable distance. It is the minimum distance what we can measure using any instrument. Suppose if you take the watch, the minimum measurement in our day-to-day watch is 1 second. The minimum distance of the ordinary scale is 1 millimeter. So like this, least count knowledge is essential for all the experiments related to measurements and quality control. Then it is also important to know these terms. Precision, it refers to the ability of the measuring instrument to repeat its reading again and again. So it is basically the degree of repetitiveness. Then there is accuracy. Accuracy is how close you are with the true value or standard value. If the measuring instrument is giving the value near to the true value, then we say that the measuring instrument is accurate. Then sensitivity. Sensitive means the instrument will show response even for small inputs. So sensitivity refers to the ability of the measuring device to detect small differences also in a quantity that is being measured. Mathematically, sensitivity is the ratio of output to its input. Then there is also an important characteristics of measuring instrument, that is repeatability. So in the diagram, you can see the input and outputs are shown along X and Y axis. Here, the measured values or the instrument readings are plotted here. The readings are clustered around this bandwidth. So it is showing the repeatability with plus or minus range. So the dark line is the actual true value. If the measured values are somewhere here, it is, you can say plus, and here you can say it is minus. So repeatability is the ability of the instrument to give the readings, same readings when the experiment is repeated again and again. That is, you can see the definition here, ability of the measuring system to respond or reproduce output readings when same input is applied to it continuously under the same conditions and in the same direction. So that is explained in this graph. Now, another important characteristics of the measuring instrument is the threshold. Threshold is if the instrument input is increased very gradually from 0, there will be some minimum value below which no output change can be detected. This minimum value is called as the threshold of the instrument, that you can see here in this diagram. See, in this diagram, the input is increased here. The input is increased and the dotted line shows that the output is remaining same. We are increasing the input up to this point. From 0 to here, we are increasing the input, but the output is remaining same. From here onwards, from this point onwards, the output is showing some changes. This point is known as the threshold point. You can see here, this is the threshold point. So what is threshold? It is the minimum value of input here, which is required to cause a detectable change in the output from 0, they say. That is, we have increased the input from 0, but only here you are seeing the detectable changes in the output. So we can define it like this. If input is increased gradually, that is from 0, there will be some minimum value below which no output change can be detected. That means below this particular point, no output change is detected here. After this, you can see the output change. That is, this is the threshold point. Up to some point, even though you are increasing the input, the output changes are not visible. So that is explained in this graph. Now, another important characteristics of the measuring instrument is the hysteresis. You can see here the input value is plotted here as x-axis. It is called as value of measured quantity. That is this one. Then here is output. Now the input is increased gradually here, and then input is decreased like this. In the beginning, input is increased. We are showing it as increasing input, and then there is decreasing input. Here you can observe that the output is different at this point when the input is decreased. When the input is decreased, this is the output. When the input is increasing, this is the output. This difference is called hysteresis error. This difference is known as hysteresis error. So you can define it like this. When any device is used to measure any parameter, first for increasing values of the measurand and then for decreasing value of the measurand, the two output readings are obtained which usually differ from each other. That is known as hysteresis. It is also defined as the difference between the increasing input value and decreasing input value, which affects the same output value. That is also another definition. So the hysteresis effect can be best understood by this graph. So why this hysteresis happens? You can see here the input is increasing, output is decreasing. This gap is known as hysteresis. Here the output is this value, but the input is same. Here you are getting this output for the same input. So when the input is increased and when the input is decreased, you get two different outputs. That is hysteresis. Why it happens? There are many reasons. So for testing of an instrument, for its repeatability, we see that input and output graphs, input-output graphs do not coincide for ascending and descending values of the graph. So there is no correlation between input-output graphs here. They are not coinciding. The non-coincidence of the input-output graphs for increasing and decreasing inputs arise due to the phenomena of hysteresis. In practice, the internal friction, sliding or external friction, sometimes there is free play in the instruments or looseness of the mechanisms are also some causes of hysteresis effects. Hysteresis effects are best eliminated. Eliminated means they are avoided by taking the readings corresponding to ascending and descending values of the input and take their arithmetic mean. Arithmetic mean is their average. So to avoid this error, hysteresis effect, so what you should do is you take the two readings, one increase the input, then decrease the input, there you will get two outputs, then take their average. By taking the average, we can eliminate the hysteresis effects. Then the terms related to the measuring instruments. One of the important term is calibration. In calibration, you have heard this word calibration, knowingly or unknowingly. Calibration is basically checking the instrument for its accuracy. The instrument is checked for its accuracy at regular intervals as specified by the manufacturer. If you don't calibrate it at regular intervals, then the instrument may not give you the desired results. So the calibration of the instrument is carried out in the laboratories by some substandards, which is used only on rare occasions, especially for the calibration purposes. These substandards are periodically checked against some standards which are held permanently in a meteorological laboratory. So calibration is basically checking the instrument for its accuracy with some known standards. Then most important thing in measurements is errors. We come across this word error time and again. Error is the definition wise, it is the true value minus result. True value is the most standard value. Result is the actual value. So if the difference exists, then we say that there is error in the measuring instrument or in the measurement process. So difference between true value and actual value can be called as error. There are many reasons for errors. For academic purpose, they are classified into systematic errors. Systematic errors means you are knowing the cause, why it happens, you will be knowing it. These errors are also called as fixed errors, and they are controllable in both magnitude and direction. So in fixed errors, it has got a value in magnitude and direction. The systematic errors, they are repeated with repetition of the experiments. These errors are constant and they are similar forms of resulting from improper conditions or procedures. So systematic errors means you are knowing its causes, why it happens, you will be knowing. They are systematic errors. So once you know the cause, you will also know the remedy. Remedy means how to avoid that, you will be knowing it. These errors can be further classified as calibration error, human error, errors of techniques, experimental error, loading error, like this. Then there are other errors, random errors. These happen, we don't know actually the cause, exact cause, we will not be knowing why the random errors happens. These are the errors which are accidental in nature and whose magnitude and sign cannot be predicted from the knowledge of the measuring system and conditions of the measurement. So we will not be knowing the exact magnitude and direction of the random errors. These random errors are further classified into the errors of judgment and errors due to variations in conditions. Then there are illegitimate errors. These are due to pure mistakes, outright mistakes. These errors are again classified into mistakes or blunders. Computational errors. Computational error means calculation errors. You calculations anna ಮಾಡ್ತಕ್ಕಂತ time ಅಲ್ಲಿ ಮಾಡೋ errors ಗೆ computational errors ಅಂತಾರೆ. Then chaotic errors. So these are types of errors. Now we will see some measuring instruments like the thread micrometer. In the thread micrometer, as it is seen in the diagram, you can see the micrometer here. It is used for measuring the pitch of the threads. Here, what is pitch of thread? You can see here, the threads are here. You can measure the pitch diameter of the threads using the micrometer. That is, this specimen is placed in between the anvil and the spindle. You have to place it in between this. You should have the preliminary knowledge of reading the micrometer. That's all required for this. So the pitch diameter is measured using the thread micrometer. That can be best explained here. There are graduations here. You should know the least count of the micrometer. Then you should know also how to take readings in the micrometer. So the thread micrometer, it uses or it gives you the readings for certain range of thread pitches. Here one thing you have to remember is, first the pitch diameter is measured for a standard plug gauge of the same size. What is plug gauge? Plug gauge is a limit gauge which will tell you the pitch diameter. So the plug gauge is of the same size as that of the pitch that you are going to measure. Then any error is there that is compensated in this measurement. So using the thread micrometer, you can measure the different range of thread pitches. So the point to be noted here is, the pitch diameter is measured for a standard plug gauge of the same size as the thread to be measured, and the compensate for the error. What are these plug gauges? Plug gauges are limit gauges which will tell you regarding the measurement of the threads. These limit gauges we will study again in detail in the next session only. Then there is bench micrometer. This is also used for taking the same type of readings. So here you can see the anvil that is fixed. This is the fixed anvil mounted on one of the ends of the micrometer. This is the fixed anvil. Then there is movable anvil here along with this dial. Along with this dial. This is on the other side of the bench. The movable anvil slides similar to the tailstock of the lathe machine. All of you have seen the lathe machine and you have also seen the tailstock. So the movement of this anvil and its sliding is similar to the movement of the tailstock in the lathe machine. Then there is also this fixed anvil you can see here. So during measurement, it gives you high precision measurements. How? The micrometer dial is here with the movable anvil. Even a slight movement of the anvil is indicated on this dial as a deflection. So if you note down this deflection, the movement can be understood. So this is the function of bench micrometer. Using this also, you can carry out the high precision measurements.